Hello, in this video we're going to talk about logic gates, and the first one we're going to talk about is the NOT gate. So this is what a NOT gate looks like. So if you see this in a circuit diagram, the one with the triangle, that one should be the NOT gate. And the thing on the left is the input, the thing on the right is the output. So the NOT gate has only one input and one output. Now what the NOT gate does is, whatever the input is, it gives out the opposite of that. So for example, if the input was 1, the output will be 0. And if the input is 0, the output will be 1. And this can be represented by a truth table. So this table on the left is called the truth table. The first column is the input, and the second column is the output. In general, the last column is always the output. So when we see a little bit more complex logic gates, just remember that the last column is always the output. Okay, this was the NOT gate. The next one we're going to look at is the AND gate. So the AND gate looks something like this, and it's got two inputs and one output. So here the two inputs are A and B, and the output is denoted by Q. Now, since there are two inputs, that could be four combinations. So there'll be two columns of inputs and one column of output. So two input means both of them can be 0. Remember, 0 was false or no current flowing, and 1 was true. Yeah, it's right here. 1 is true and 0 is false. So if they both are false, it'll be false. If one is false and the other one is true, it will be still false. Similarly, 1, 0 will give you 0, and 1 and 1 will give you 1. So for example, if they both were 1 and 1, what you do is you look at this row, and whatever the output is should be on the other side. If it's 1 and 0, you look at the third row, 1 and 0, and the output is 0. The example of AND would be, so if there were two sentences, say the sun is yellow and today is a Sunday, something like that. So one is true and the other one is false. So it means one is true and the other one is false. So overall it has to be a false because it is a AND. Okay, the third gate we're going to look at is, let me just check if I'm recording. Yeah, we're recording. The third one will be called the OR gate, which looks like this. And once again, it's got two inputs and one output. So just like we have two inputs, we should have two columns as inputs and one output. Now, the only difference in OR and AND is it is only false when both are false, and it is true every other time. So for example, if 1 and 1, it means both are true, then true or true is true. True or false, since it is an OR, true or false is a true. Only when false or false, overall the output will be a false. So that is the OR gate, and it looks like this. If you see this in a circuit diagram, you should recognize that this is a OR gate. We'll do one more gate. It'll be called XOR gate, which is called exclusively OR. So it's similar to OR. It's got two inputs and one output, but the only difference between XOR, XOR, let's say, and OR is that when they both are true, it is a false. right? And this is like an example of the lock system in real life. That if there are two ways to open a lock, if they both are true, then it cannot be true overall. Okay, now mathematically to write them is called the Boolean algebra notation. If it's A and B, we will say A dot B. If it's A or B, we'll say A plus B. Not A, we can write it as A with a dash on the top or A with a slash on the top. And A XOR B will be A with this symbol and B. So now when we do examples, you will have to write the output in terms of the shorthand notation. Let's see an example now. This is an example which combines the OR and the NOT gate. So if you look at the first one, it's the OR gate, and then the OR gate connects to the NOT gate. Now, step one in solving any such examples is that you identify how many inputs are there first. So for this example, we have two inputs. So step one is make two columns, A and B as your inputs. And since there are two inputs, there are four combinations. So 0, 0, 0, 1, 1, 0, 1, 1, right? Because they both can be 0, one can be 0, the other one can be 1, then 1, 0, and 1, 1. Now, what is the output of A and B? Is a OR gate, which is denoted by A plus B, which is here denoted by C. So C is A plus B. To get the output here, we have to look at the OR table. Now remember, OR is false only when both of them are false. So 0 or 0 is 0. Every other time it is 0, 1, 1, 1. So at this stage, in the NOT gate, 0, 1, 1, 1 is going in. So this column 3 is the input for the NOT gate. And what the NOT gate does is it will take the input and do the opposite of it as the output. So 0 will become 1, 1 will become 0, 1 will become 0, and 1 will become 0. So your final output is 1, 0, 0. And to write this in the Boolean algebra notation is there are two inputs A and B. A and B, two inputs. What is happening first is the OR gate. So A plus B is happening first. And then A plus B is going into the NOT gate, and the final output is the opposite of the NOT gate. So we put this in a bracket and a dash. So if you look back here, A plus B was your OR gate. So this was happening first, and then the NOT gate. So the whole A plus B is becoming with a dash. So this is the first example. This is like the basics of logic gates. We'll do more examples in the next video. And if you have any questions, you can put them in the bottom. And I'll stop recording.